Oh,
So
sorry,
if
just 1 second, Jane. Right, there we go. Our second speaker is Joe Hampson. He's the Honeygar Wilding Officer at Somerset Wildlife Trust, helping to lead and coordinate the development of the Trust's most ambitious project to date. Joe, over to you.
Thank you very much. Yeah, so first of all, I'd say thank you to the Biological Recording Company for having Jeff and I talk today. It's a really exciting time for Somerset, for the Somerset Wildlife Trust, and I think for environmental monitoring in general, in light of all these new innovative technologies that we have to monitor these environments. So today I'm going to talk about Honeygar, particularly focused on bioacoustic monitoring that we're doing on site, but also give a bit of context for Somerset as a landscape, what we're hoping to achieve with the site, what changes we've made, and kind of future direction of the site as well. So Honeygar, this is a small map of Honeygar that we have for the site. So Honeygar is an 81 hectare, formerly quite intensive farmland, which is quite indicative of agriculture on the Somerset levels. Predominantly, it was used as a dairy farm, had about 120 to 140 cattle on site, which is around 1.5 stocking units per hectare. And we also had some quite intensive land management practices taking place here. So Honeygar, I think it's also worth mentioning, was formerly split into two land holdings. So we've got this land holding here on the east, which was used for much more intensive management practices. Lots and lots of deep drainage because we're on peat soils here, predominantly used for silage cuts, and there was some maize grown on site as well. So really quite intensive land management practices. And to the western side of the site here, it was used a lot less intensively. There was a lot less drainage of the site. It wasn't used for silage. It was just used for hay cuts, had some cattle on site aftermath grazing. And when we bought the site, there was already some really big differences between this eastern and western side of the site. So I think overall, the Wild Intense project, it's really interesting because we're not just looking at one particular site that's had a certain legacy of land use. We're looking kind of at two kind of separate sites that were kind of into one. So as we're evidencing those changes, I think it's really important to understand that as a basis. So when we talk about Honeygar, we talk about kind of our three key messages for the site. So the first is that Honeygar is a vital site within the nature recovery network. The second here is that Honeygar is a unique opportunity for the Wildlife Trust because we are taking a wilding approach to our site, which is very different to how we manage our reserves elsewhere within the county. And the third and final one, which kind of ties these first two together, is that Honeygar is a catalyst for change. It's a flagship site. So a lot of the land management changes that we're taking on site through changes in cutting and grazing and through changes in hydrology around water management, we want to be able to guide other landowners within the area. So as part of the Somerset Wildlife Trust, we have an Elms Landscape Recovery project, which is piloting the new highest tier of the agricultural policy. And we have about 1,500 hectares within that. So it's hoping that a lot of the changes that we make on site will be able to guide other landowners within the area to do the same thing, but also working closely with our partners as well. Partners like Natural England, Hawke and Owl Trust, RSPB, which sit, within the Avalon Marshes landscape as do we. So any changes that we make around, monitoring, can it also be taken on other reserves as well to kind of build up that bigger picture going forwards. So I'm going to bring us back to our first kind of key aim for the site, which is our nature recovery network. So you have a couple of maps here with lots and lots of colors. This is an ecological network map. So the different colors will denote different habitat types. So we have the greens here, more species-rich grassland. We have the pinks here, more heath and acid grasslands, and the blues here for more wetland habitat sites. You also see there's an awful lot of white on this map. So areas of white on this map denote areas of really quite low habitat quality. And you'll see Honeygar, which is this strange polygon right in the middle here. You can already see, as I mentioned previously, we've had some really different land uses across the whole site in its history, and that's represented here through the differences in the high quality habitats that exist. So currently, we think around 10% of the county is managed positively for nature as a kind of overarching goal for the Wildlife Trust. 30 by 30, we'd like to see that triple to 30% of the land and sea being managed positively for nature by 2030. And that's a really big ask. You can see here there's an awful lot of white on this map. And another issue that Somerset Levels has is that land is highly fragmented. You know, you have lots and lots of landowners that might have a field here, a field there. So kind of starting to connect up these habitats is going to be really difficult, and it's going to require us to be working really closely with our partners in Natural England, RSB, Hawke and Owl Trusts within the local area, but also working with local councils, working with schools, churchyards, and also landowners within this landscape as well. So it's gonna require, you know, all of us singing off the same song sheet, excuse the pun, to be able to have the change that we need. In the past, conservation organisations like the Wildlife Trust have focused really heavily on these already really existing high quality habitats. You know, just here, the top right of this picture here, we've got parts of West Hay Moor. To the west here, we've got Teelham and Taddam Moor. And to the south of Honeygar here, we've got West Hay Heath and Catcop. And these have been managed positively for nature for quite some time and are already really fantastic. But we now know that that's not enough if we are going to, you know, if nature is going to recover within the county, we need to be able to connect up these habitats. And that's where Honeygar sits in. Honeygar was strategically acquired partly because of its position in the landscape. And it's hoped by restoring nature at Honeygar, Honeygar is then in future able to act as a green stepping stone, connecting and buffering up these already existing high quality habitats. So I'm going to talk about our second kind of aim now as kind of context to the wilder sensing project. So when the Somerset Wildlife Trust purchased the site, we undertook a lot of different changes to the site. The first being around cutting and grazing for the site. So as I mentioned at the start, prior to the trust purchasing Honeygar, we had around 120 to 140 cattle on site. We reduced that number right the way down to about 40 livestock units across the whole site, which is 0.5 stocking units per hectare. And it's the same stocking density as Frans Vera's project in the Netherlands used Vadersplassen as a kind of a basis for the site. We also limited silage cuts on site. We were only silage cutting in this kind of northeastern parcel of the site, which was recently reseeded with perennial rye and clover prior to the trust purchasing the site. And the aim of continuing silage cuts in this area was to kind of reduce those nutrients down going forwards. So it also changes how we're grazing the site. Initially, we trialed kind of a low density kind of mob grazing of the site where we had cattle move from compartment to compartment every week or so, kind of simulating natural movement of the herd, even dung spacing across the site, and also allowing these fields to rest after they've been grazed. And at the end of the year, we had kind of a mosaic from field to field of where we had the grazing at the start of the year in this northwestern side of the site. Slowly the sward reduces, we're kind of moving our way around. So we've got that variation here. Now we're moving more towards continuous grazing of the site. to really allow nature to take the lead on site. At this stage, we are using a mix of Friesian and Hereford cattle. But as the site develops and as it gets wetter and those nutrients start to go down, we're exploring the option of different stock that are better suited to grazing more wetland habitats. So looking at things like belted Galloways, which are fantastic, really small, compact, limit compaction on the site, can be out all year round and eat a lot more of the rougher grasses, but also involving grazing by ponies, probably going to be Exmoor ponies on site, and maybe some goats as well. And with that, to have a whole range of animals that are doing very different things on site and allowing kind of nature to take the lead in that sense. I think it's worth mentioning at this stage as well that we are making changes in management on site around cutting, grazing, and hydrology. But those changes, it's all about transition. We won't be managing the habitat for any particular species. So say, for example, in 5 years' time, when the site's a lot wetter, we get loads of really nice wetland species on site. We might go, fantastic, we've got them now. Let's put in loads of scrapes and do all sorts of extra things to make sure they stay. It's all about taking a wilding approach, monitoring it effectively as we go on, and allowing those transitional habitats to develop, and really allowing nature to take the lead, which is, of course, very different to how we manage our reserves on other sites. So the second one, and probably the biggest change that we'll be making on site, is all around hydrology. As I mentioned, we're right in the heart of the Avalon marshes, right in the heart of where a lot of our peat soils are in Somerset. Really good in the past for agriculture. You're deep draining it. You can have a lot of cattle on site, but we want to change that, because we now know that all of the management practices, particularly around lowering water tables and draining water tables, are having a huge impact on carbon dioxide emissions. We predict that around 300,000 tons of CO2 is released every year from management practices around peat soils in Somerset, which is equivalent to about the size of a town every single year. So it's really quite significant. We've got some quite deep peat at Honeygar. Average across the site is around 2 meters. We've got some areas that are 3 meters, and we think our recent calculation of about 100,000 tons of peat of carbon stored within our peat soils at Honeygar. For those of you that don't know the Somerset levels, it's a highly managed landscape in terms of hydrology, starting way back in the Roman period, when they started to drain the land for use in agriculture. And that's got more and more sophisticated as time's gone on, and more intense. And it's led to a state now where all of these boundaries here and these field parcels, these are all ditches. They're called rines, wet hedges in Somerset. So it's a really complicated network of ditch habitat here, crisscrossed by these blue lines here, which are viewed greens. They're basically essentially wider, larger drainage ditches that they're called viewed greens. They're previously viewed on horseback. But essentially, all of our internal ditches drain off into these wider drainage ditches, which then go into even larger drainage ditches, and then eventually, you can see this up in the north of the site here, into the River Brue, and it's all taken off the site. It's all about getting water off the site as quickly as possible and draining the land for use in agriculture. We want to change that at the Somerset Wildlife Trust. We understand that status quo is we can't go ahead. So one of the initial changes that we've made on site is to start to block up some drainage ditches. So you can see here all of these non-return valves here. These are all steel bunds, and I'll show you some pictures of that in just a second. But you can see that they're all coming off of these viewed greens. So with all of these structures in place, we are holding higher water tables. And to do that, we're relying on winter rainfall at this stage to kind of top up our ditches. And yeah, so we're not losing water so quickly on site. So these are some of the sheet piles that I just spoke about. So they are 4 by 5 meter steel sheet piles, which are driven into our internal ditches, and they're fitted with a non-return valve. And that non-return valve is set at the level set by the IDB. So the IDB, the Internal Drainage Board, they control water levels within those viewed reams in Somerset. So prior to these structures in place, the water levels in our ditches at their highest point were at the point set by the IDB, which is 1.6 meters, something about 40 centimeters below where we want it on site, and that was our highest level. Now we've got these structures in place, we can top up water right the way to the top of our sheet piles before they fill over. And if the water level ever drops below the level prescribed by the IDB in the wider drainage network, we'll get a direct feed from these structures. So what essentially was our highest level is now our lowest level that we can achieve on site. Here's just a few more of our structures. So we've been filling in some field gripes on site as well, putting in structures like this U-bend here, so it will only top over into the drainage net, into the ditch once we reach this top level. And we're also exploring the use of low-cost solar pumps as well to kind of keep it topped up to that level. So we want it to be constantly trickling over the whole time, keep that really set, standardized level of 10 centimeters below the surface of the soil, which is the level Professor Chris Evans has shown to be the best at reducing carbon emissions, kind of that balance where you're reducing carbon CO2 emissions enough, but you're not heavily increasing methane emissions by having the water table too high. So just some changes that we've seen on site as a result of hydrology. So this was the winter before last, and this winter just gone here in this location. So it's slightly skewed. We've had one of the wettest winters, I think, since records began on site. But just to put it into context, this year we've held 340,000 cubic meters more water than we did last year, which is around the region of 126 Olympic-sized swimming pools. One of the issues that we're having though is that we can hold all this water, fantastic, during the winter, really, really high water tables. But as soon as the rains stop and summer's kind of started, those levels kind of really drop off quickly. So it's not about getting the water, because we are getting a lot of water at the moment. It's all about holding on to that water, which is proving a real challenge for the site. And the third and final thing, which I'll touch on just briefly, is that Honeygar is a flagship site and a catalyst for change. So as I've mentioned, a lot of our practice that we're doing on site, we are pouring a lot of resources into monitoring the changes that are resulting from those changes in management practices, and also trialing new innovative monitoring techniques as well, so we can have the best case to be able to evidence this change, be it positively or negatively. We'll be able to, we've got the data there to be able to show robustly that our changes have resulted because of this. And we do a lot of outreach, be it through media outlets or be it through tours on site. We're always bringing people on site and going to other sites as well to learn from what's happening elsewhere within the county, but also further afield as well. So why everyone's here, I'm going to be now, for the remainder of the talk, I'm going to be talking about monitoring on site. So I won't be touching on all of this today, but just as a kind of a list of the kind of things that we are monitoring on site, because it is quite vast. So as I mentioned, we're doing some greenhouse gas monitoring on site across a number of points, utilizing the chamber method. And we also have loads of dip wells on site as well. So you can see here in the top left, this is a dip well. It is essentially a slotted drain pipe, which is pushed all the way down into the peat profile, down into the underlying clay below. And that's monitoring our water table depth across the site. And we have 38 of these across the site. We have 20 or so tied to our greenhouse gas monitoring points, as water table depth is the key variable when looking at greenhouse gas fluxes. But we also have a number which are in transects as well. So we're looking at changes in water table as we move from the ditch edge right the way to the center, that lateral movement of water, which is really important that we do so. And as you can see here, we also have peak cameras measuring the height of peat as it expands and contracts as a result of weather events. We also have a weather station as well, which is monitoring a whole range of variables on site, from temperature, humidity, wind speed, wind direction, evapotranspiration, which is really key, I think, for this project in general, and also the wilder sensing project. And you can see here in yellow, we also have a lot of species monitoring on site, from flies, bee transects, butterflies. We've just started dragonfly surveys on site, and also small mammals. You can see here just a bit of a whistle stop of some highlights. We had 108 harvest mouse nests found this year. We've had 110 species of moth recorded. We've had some rare bryophytes found on site. And more recently, as a result of setting up a water vole monitoring project, we've had water vole and otter found on site. So now I'm going to talk about the wilder sensing project. The wilder sense, I brought this slide up again because I think it's really key. The wilder sensing project is fantastic for us at the Somerset Wildlife Trust, because I think it really ties in to these three key messages for the site. We'll be able to monitor nature's recovery, species monitoring through these sensors. It would also enable us to demonstrate the effectiveness of our wilding approach, what's changing on site as a result of our management practices. We're getting continuous monitoring of birds on site. And also this final point of Honeygar being seen as a catalyst for change in the flagship site. These are very innovative sensors. They're very new. I think they're fantastic. They produce an awful lot of data. And we're already starting to see that change now. So we have, in the past, we had 4 sensors on site, which I'll speak about in more detail in a little bit. But we've just started an expansion of this project to look at it across a wider landscape. So already these sensors, as a result of the million+ records that we've had, we've shown how effective it can be at monitoring these landscapes. So we're wanting to employ it to employ it elsewhere. So where are the sensors on Honeygar? So we have 4 sensors across the site, or had 4 sensors across the site, and in just a range of habitats across the site here. So we have one here, 6310, which is the south of the site, and this is more in kind of open field habitat, which is neutral grassland. So not too close to any kind of hedgerows on site. We then have another sensor up here, 6342, which is along a stand of oaks, and it's also really close to the farm buildings as well, and it's within a patch of scrub. Then we have 6308, which is in one of our small non-intervention areas on site, which is kind of in the center, kind of a mixed copse kind of corral, all different species of trees in there, and a bit of a microhabitat as well, because less impact from wind and such in that area. And we also have one down here, 6324, which is where Jeff mentioned the Chetty's warbler had been found on site, is along a very overgrown ditch, another stand of kind of oak trees, and it's also right next to an active peat works as well. So there's a lot of activity within that area. So we've had 4 sensors for about 20 months. We've generated over 1.3 million species records, which in itself is absolutely fantastic. It's a huge number. And as the projects moving forwards, we will be generating an awful lot more data as time goes on. So what kind of insights have we picked up so far as this project? So this is, apologies, a bit of an older number here, but we have picked up a whole range of different species of birds within those 1.3 million+ records on site. Some more common. You've got things here like the wren, which absolutely loves calling, is really loud, and then other things less so, but some really interesting insights from it, like the Chetty's warbler, on site, and also some really quite rare species, which I will touch on as well in a moment. But I think one of the benefits of wilder sensing is within its analytics platform as well. You know, you're getting an awful amount of data from it, but the analytics platform allows you to be able to view this data in very different ways. And it allows you to pull insights out that you're able to use within your own comms, or able to be able to start looking at trends. I think having people working on this, it could be, a PhD project for years and years. The Honeygar project is at least 50 years long, as dictated by our commitment to wilder carbon and carbon credit scheme. But we anticipate this project to be in perpetuity. We're going to be monitoring changes as time goes on. So within that, there is huge scope for research, looking at things very broadly. How is bird assemblages changing, but also digging into the data and looking at kind of more species specific data. So for things like the Elms Landscape Recovery Project, or kind of more farmland based studies, you can look at things by farmland bird index, see how that is changing as time goes on. And as time goes on as well with this project, so the analytics platform will be, changing and increasingly better to suit the needs of multiple users with much different outcomes that they're hoping to achieve. So just to dig into some of the more kind of species focused stuff on site and what it can potentially demonstrate. Up here on the top left, we've got some recordings of a night heron on site. And this is an interesting story, really. And I think it really demonstrates how you can utilize continuous recording. You can utilize the power of AI, but also the power of people as well. So we are still doing breeding bird surveys on site, wintering bird surveys on site, breeding wader surveys on site. Those are still taking place, and they're not going to go anywhere anytime soon. And last year, during a breeding bird survey, we had a night heron spotted on site for about 20 minutes, which is really lucky, really fantastic, really quite rare bird for the area. But because we had that sighting on site, we were then able to go back through our records and see, when else has this night heron been heard on site? As it mentions here, it needs validation. And we will do that for, rarer species found on site. And there are a fantastic wealth of knowledge within the local area that are able to help manually validate these records. But it meant that having that bird survey on site and then being able to have this data, it meant that we could go back and see when else it had been heard. And conversely, if we heard something particularly fantastic, Jeff mentioned earlier about the corncrake, but if we'd heard that and it had actually been the corncrake, we could then do a targeted survey to that area to assess its presence. So it kind of works both ways. The field surveys can really help with our wilder sensing project, but also the wilder sensing project can also help us to target surveys in future. Another one here that Jeff mentioned in the bottom left is this Chetty's warbler, calling almost exclusively at 3 or 4 in the morning for April and May throughout the year. And unless you are particularly keen and out all night wanting to do your listening to birds at 2 in the morning, this might be something you miss. So it enables us to pick up data that traditional field surveys simply couldn't, because we're recording 24/7. Another one here in our kind of top right hand corner is the number of I think it's the number of snipe. Yes, number of snipe on site. So you can see here we had some big peaks in the winter 2023, and as dropped off, and some bird got lost here somewhere in the middle of June. And as we move back into winter, we start to see trends of birds appearing again. And that's really important to us as the project progresses. As I mentioned, we're a wilding site. So to be able to demonstrate how species are responding to these quite new changes that we're doing within the landscape is really important to us. Every year, as the site gets wetter, we'll be able to tell from our dip well data and from our weather data just how much wetter it's getting, but how a bird species assemblages responding to that and how our individual species responding to those changes over time, which I think is really fantastic. And looking at things in a longer time frame as well, looking at things around climate change for the site. How are species changing as a result of climate change? Are species arriving earlier and sticking around for a lot longer than they were before? Are we getting new species in? With our weather data, with our hydrological data, other species data, and this, I think we'll have a really good shot at being able to demonstrate that change and how Somerset is changing as a result of climate change and a result of more targeted management practices.
Joe,
so hello.
Sorry to interrupt you, Joe, but we've kind of got to the end of the session, and I can see that people are starting to drop off. So apologies for that, but yeah, I just want to make sure that we wrap up properly at the end of the session.
Okay, this is my final slide. I can whip through it in a minute if that's okay.
Yep.
So apologies for overrunning there a little bit on time, but this is our expansion that we've planned and we're currently underway of implementing. So this is Honeygar right in the middle here. We've increased our sensors for birds from 4 to 8 across the site, and we also have 3 bat sensors. And we also have 3 bird sensors at West Hay Heath here and at Catcott, and to the northeast here at West Hay Moor and a bat sensor. You think you can see that from this map that we are really now starting to look at species monitoring on a continuous level at a landscape scale rather than just a local site scale. And it's hoped that the more and more data and buzz that we generate around species recording in this way, that more and more partners within the landscape take this on. We've just had, I think, 10 sensors at a Natural England site to the southwest of Honeygar take them on as well, which is really, really fantastic to us. I think we'll be generating something like, with just 8 bird sensors, I think we'll be generating a terabyte's worth of data every 2 weeks. So if you look at that over the year, we could be generating almost 20 terabytes worth of data. Fantastic. Lots around data storage and how we're going to best harness this data. We're working really closely with the University of West of England, and we'll be hopefully working with other academic institutions to kind of pull those insights out as time goes on. But overall, I think we are really looking at a new age in kind of species monitoring on site, and a very exciting time for the Wildlife Trust. So thank you everyone for your time, and if you've got time for questions, I'll take them. If not, I'm sure my email can be shared and I'll be more than happy to address any questions.